Hi everyone, welcome to this video on lesson 13 of the Sound and Light scheme. This is on short and long sightedness. And this is one of those lessons where it's not really a massive part of the spec, and at GCSE, there's not going to be loads of marks available in a GCSE physics paper for answering questions about short and long sightedness. And yet I still think it's an incredibly important lesson to cover with students, just from a kind of general knowledge point of view, because so many of them and so many of their families and friends will wear glasses or contact lenses or whatever, and actually understanding what it is that's going on and why it is that young people tend to be short-sighted, whereas when people get older, and they're reading a book or a newspaper, they have to hold it miles away from them, they tend to be long-sighted. Hopefully this lesson and the subsequent lesson on correcting vision will give them a sense of why that is, so they can actually understand what's going on in the world and it not just be a mystery. But it's also important because it's a really good way of reinforcing this broader concept that we've been looking at, which is how light behaves. And really it comes back to loads and loads of practice at drawing ray diagrams and just thinking about how we represent light. And also thinking about what light can do at a boundary, and one of the main ones is that it can refract and change direction. So by keep coming back to these ideas of light refracting and so on, hopefully students will have a really secure understanding of what's going on there by the time they get to their GCSE studies. So I think it would be helpful before you start this lesson to recap on what we did last time. So I've got the diagram here. So this diagram that we sketched out last time of how light is refracted by the eye for distant objects versus for nearby objects, and the fact that the lens has to become fatter. And we can start by recapping that, but in this case we don't need to spend so long and draw such a kind of intricate diagram of all the different parts of the eye. We can keep it really, really simple. So the way I might lay this out to students would be to kind of have distant and nearby objects side by side. So let's start with distant objects, because that's a bit like what we did in the lesson on converging lenses. So if we start with distant objects, and then over on this side we can put nearby objects. Like this. So let's start with the normal case. What should happen? So what should happen if we're viewing distant objects, and we can represent distant objects like this, with light rays coming in parallel to one another and to the normal. So light is coming in like this. So if this is our eye here, I'm just going to draw it as a really simple circle with the lens in here like this. Again, you can ask students, you might want to start by doing this on whiteboards or something like that, ask them to sketch what it looks like. What they should remember is that for distant objects the lens becomes relatively thin, because we don't have to refract the light that much. So then you can show this. I will continue my diagram like this. You can show this. If the lens is relatively thin, then that light all focuses at one point, which is on the retina where it's supposed to be. And this is a bit of a fiddly diagram, but hopefully we'll get it right. And all the light should focus there as it's supposed to. But then you can say, sometimes some people have a bit of a problem. So let's draw the same thing again. Let's draw these three parallel rays of light coming in from a distant object. And what you can say is, well, for some people, the problem that they have is as follows. I draw my eye here, like this. Now, where the lens within the eye is supposed to be thin for distant objects, for some people, their lens just can't quite get thin enough. It stays a little bit too fat, like this. And again, this is a really good opportunity to just reinforce some of these ideas that we've covered earlier on in this unit. Okay, so if I've got a lens that's a little bit too thick, is the light going to be refracted more or less? I'm going to check for understanding by asking the whole class to show me in the thumbs, or you could use whiteboards or whatever as well. You want to elicit the idea, okay, if it's fatter, if the lens is a bit too fat, then the light is going to be refracted a little bit more. What does that mean? Well, it means the following, and you might want to question them to elicit this, or you might just want to explain it to them. But what happens is that actually light gets refracted a bit too much, so the focal point is not quite on the retina. So what happens is this, it all passes through that focal point. This one can just go straight through, whoops. This one goes through like that. But the point being, if your focal point isn't on the retina, if the light isn't actually being focused on the retina, you don't get a clear image. The image you get is blurry. So there's a problem here. And again, how much you want to label depends on the class that you've got, because what you're going to be asking them to do towards the end of this lesson is write about this. So if you want to add some little notes to this, that's absolutely fine. I'm going to, in this case, I think I'm going to keep it quite sparse. But the main point to illustrate is that in this case, if your lens is too fat, then the light doesn't focus on the retina. This is what we call short-sightedness. So short-sighted people, and this sounds really, really obvious to an adult who's got their head around this concept. Students actually find this really, really difficult. Short-sighted people can't see things that are a long way away. So this would be an example of short-sightedness. I'll just put short-sighted there as well. So this is short-sightedness. The fact that the lens is too fat and distant objects, you can't focus them on the retina. The focal point is too close. You can't get your lens thin enough. And it's worth stressing to students that this tends to happen in younger people. So younger people tend to have lenses that are a bit too powerful, and therefore they just can't get thin enough to allow those distant light rays to refract to the right point. And it's maybe easier when students are trying to remember who gets long-sighted, who gets short-sighted. It's maybe easier with the other case, which is long-sighted, as we shall see. So let's draw our second pair of diagrams over here, and this is to do with looking at nearby objects. So let's remind students what we want to say. Let's just start that again. With nearby objects, we're not getting these parallel rays of light, essentially parallel rays of light coming in from a long, long way away. We're getting rays of light coming from a point which is a lot closer. And what you want to remind students is what should happen in the normal case is that the lens makes itself nice and fat, like that. So it becomes very powerful. It can bend these incoming rays of light an awful lot. That one straight through. This one can go like that. It can bend these rays of light. It can refract these rays of light an awful lot in order that they can get those rays of light focused onto the retina. So this is what should happen. But then you can tell students that what sometimes happens is the following, that actually a person's lens just isn't strong enough to get that fat. Your muscles can't squash the lens enough to make it so fat. So what happens is the lens is just a bit too thin, like this. It can't get fat enough, and I'm exaggerating here, but it can't get fat enough to really refract those rays of light as much as they need to. So what happens? Well, this is what happens if I draw that one going through and this one over here like this. Essentially, these rays of light cannot refract enough. Therefore, they end up only being focused somewhere, some imaginary place behind the retina. Now, it's important that students don't think rays of light are passing through the retina and ending up, somewhere in your brain or something like that. So you can you might wish to sort of, if I rub this out actually and do it as a dashed line, so you might say, okay, behind here, the rays of light don't actually arrive here, but there's this kind of imagined focal point which we have back here, like that. So I'll do that a little bit fainter than I would have done otherwise. But the point is, again, the main thing students need to recognise here, the Holy Grail, what we're looking for in the eye, is for light to be focused on the retina in all cases. In this case, the lens was just a bit too powerful, so the light was focused before the retina, and you couldn't get the focal length long enough to get it focused on the retina. In this case, it's exactly the opposite. So because you can't get the lens fat enough, the lens is not powerful enough, it's a bit too weak, therefore the focal length remains a bit too long, and you can't bring the focal point onto the retina, it's always going to be a bit behind. So again, what you would encounter here is a bit of a blurry image. And this is the opposite effect, where this is short-sighted, so it's people who can't see distant objects. This is long-sightedness. This is people who can't see nearby objects. So this is long-sightedness. And again, I think this is a bit easier. It's a bit easier for students to get their heads around this. Long-sighted people, their lenses are a bit too weak. That's what happens when you get older. And the muscles aren't quite as strong, and they can't make the lens fat enough to focus the incoming rays of light in the right place. And again, I should have started with this, and when you're doing the lesson, do start with this. Draw on the experience the students have of this sort of stuff already. So, you might want to ask them who wears glasses, and get them to talk about the experience they have. Ask them to take their glasses off and say, well, can you see what's on the board? Oh, no, it's a bit blurry. So get this idea that things that are quite a long way away from those students who are wearing glasses, because they will almost certainly, most of them will be short-sighted, things that are a long way away, they are going to be difficult to see. Then ask them if their parents or their grandparents or whoever, someone a bit older, wears glasses. And hopefully you'll be able to draw out this experience of seeing old people having to take their glasses off or put their glasses on in order to read something that's quite nearby. They really struggle, older people, to see things that are nearby. And again, if students recognize that contrast and start to build up this picture, you can then bring in these more abstract concepts about the lens to help them explain that. So this is just an introduction. I've broken this sequence or within this sequence of lessons, I've broken the lessons up into quite small chunks, let's say, because I think it's worth just taking our time to break it down rather than trying to throw everything at them. Okay, first we saw the eye, how it should work. Now we're seeing where it might go wrong. What you're going to see in the next lesson is how we can use artificial lenses, i.e. glasses, to correct both short-sightedness and long-sightedness. So that's what will come in the next video.